Guys, so today's problem is 32 longest valid parentheses. Okay, so just uh the 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 problem is the description is short to understand. It's very short to understand. So we have these two test cases for us. Let's just write down something here to get inspired. Okay, so first one is this one, the one two. What can we do? Inspired by the problem valid process, I actually wanna try something. Try using stack, and because we have this keyword longest, so let's keep an eye on this max length. So what if we just do what we did in valid process? So it should be at first this left process, and next this one. Okay, and since we encounter with this right one, so pop out. But what do we get now? We get you know what? Because longest has something to do with length. So because it's of length problem, so we should have something with with the indices of the process. So how about this? How about we just push this on the stack, and then one, and when we encounter this right one, we pop out our one, then it's 0 here, and our max length is 2, which is 2 minus 0. Alright, am I right? Yeah. So maybe it's a valid solution. So let's look at this one. Cool. So 0, 1, 2, 3, 4, 5, and now a stack max length to keep an eye on the length. So 0, and oh no, let's say what if the first one is right processes what can we do? We do nothing. So if, let's say, if empty, if not stack, let's say, and of course if this one, and if not stack, we're gonna do nothing. Okay, so first do nothing, and next we push one onto a stack, and then we encounter with this write process with index of 2, and we pop out. Okay, so what do we get? We get here, because 0 is on top, but there's 2. Should at this place should be 2, but you know what, we have nothing in stack now. So how about we still push 0 onto a stack, even if it's the right process, the parenthesis. Let's say no, because that's not even a valid solution if we encounter with this. For example, we encounter with this the third one was the right parenthesis. So here we go. Let's just prove it. If we still push this onto the stack, then 1, then 2. So because we meet this one, and if this and not stack, we still push the index, then it's okay. But if stack, so else we're gonna pop out. So this, there it makes sense. Okay, so pop out and let's say max length is max of something, comparing with the current one and the current one and the previous one. Next, we have 3 onto the stack, and then we have 4 minus 0 is 4, so it's 4 here. Next is 5 is this one, right parenthesis. So what to do? This one. Okay, so how about we have this 6 and 7. Then 6 and back and pop. So still it's 2 and max loss to 4. So maybe it's valid. Why not use another another test case? Let's say we have too many right parentheses. So like this. Yeah. How about this? In the last we have, in this place we have this. Yeah, just not too many. Okay, so 1, 2, 3, 4, 5, 6, 7, and the stack max length is, I don't know now. So 0 here, 1 here, and we meet 2, so pop out. Then 2. Don't worry, we have 3 here. So wow. So it's 3 here, but our answer is what? Yeah. Our answer. Oh my god. So our answer is not correct here, but you know what? If we have this this arrow here, what to do? maybe we just put -1 here at first place, and 0 here, 1 here, and when we meet 2 pop out, so the current max length is 2, and then we have 3, but still pop out this one, so 3 minus 1 is 3 plus 1 is 4. Okay, let's meet this 4. Just pop out. Okay, so that's another error here, because at first we have -1, even if we have -1 here, but this 4 will pop out this -1, and we have nothing to compare with, because here we compare actually using max length and the current index minus stack top. So stack so we shouldn't pop out here, but how about pop out here? Then this. So I guess that's valid answer. -1, and oh no, let's just get started still from the first test case. So -1 and 0 and 1, 2 pop outs, so still, yeah. How about this? -1, 0. Oh no, -1, the 0, pop this out, and if not stack, so push this, and we have 1 and 1 pop out, 2 minus 0 is 2, and we have 3 here, and when we meet 4, pop out 3, so 4 minus 0 is 4, and when we have 5, pop out 0, but it's M. Oh, actually it should be here. I'm so sorry about that. Here, yeah, that should be perfect. And we have 5 on top, then 6, then 7. Okay, so our this very complex test case to challenge myself. Yeah, -1 and 0 and 1 and 2 pop out this, and 3 pop out this, so 3 minus -1, 4. So then 5 here, 5 pop out this, and then push 5 itself in. Oh, sorry, it should be 4. Yeah, and then we have 5 and 6 pop this out, but still 2 less than max length, so do nothing to it. And we have 7 here, so 7 is a loss in this. In the end, this deck has only 1 7. Okay, so I believe the code is simple, but this process of thinking is very important, much more important than the code itself. That's fun.